Good afternoon and welcome to today's webinar, Analytics in the Clinical Laboratory with R, an Expert Panel. AACC is delighted to bring you this webinar in collaboration with R Medicine. This expert panel will be moderated by Dr. Shannon Heyman, Vice Chair of Computational Pathology at Lurie Children's Hospital of Chicago. So let's get started. Dr. Heyman, you may now begin.
So I'm going to kick off the session by allowing the panelists to each briefly introduce themselves, and then we will go forth into the panel discussion. Do we want to start with Dan Herman?
Sure. Good afternoon, everyone. I'm an assistant professor of pathology and laboratory medicine at the University of Pennsylvania, where I direct our endocrinology laboratory, which is basically a special immunoassay laboratory, and I help support clinical informatics and analytics for our department.
Dan Holmes?
Hi, I'm Dan Holmes. I'm Director of Pathology and Laboratory Medicine at St. Paul's Hospital in Vancouver. And I sort of do everything that Dan Herman just said. I direct the Special Endocrine Laboratory, the Mass Spec Laboratory, and I help out with analytics.
Perfect. Stefan Kadauke.
Hi, everybody. My name is Stefan Kadauke. I'm an assistant professor of pathology and lab medicine at the Children's Hospital of Philadelphia. I'm the assistant director of the Cell and Gene Therapy Laboratory, and I'm also a member of the Division of Pathology Informatics, and I lead Cell and Gene Therapy Data Operations Group.
Great. And Patrick Mathias.
Hello, Patrick Mathias, Vice Chair of Clinical Operations in the Department of Laboratory Medicine and Pathology at University of Washington. I'm the Associate Medical Director for Informatics in our department and the Medical Director of Point of Care Testing for Airlift Northwest. My primary clinical responsibility is oversight of informatics for our department in our reference laboratory operations.
Perfect. And I know all of you are our users and our educators, so I think that makes you very well equipped to be experts on our panel today, so thanks for joining us. So let's start. So we're going to cover, actually, the way this is going to work. We're going to have a moderated discussion. Then we're going to actually treat you to a couple of show and tell, where our panelists are going to actually show how they've used R in production within their laboratory. And then we'll come back and do a little more discussion. And as was previously mentioned, at any point through the webinar, if you have a question, please put it into the Q&A. And we'll be monitoring that and can incorporate questions or answer them as we see fit. So let's start off our discussion. Dr. Holmes, why don't you tell us what is R?
So R is what we call a scripting language. It's a programming language, but it requires you to install R on your computer, the R interpreter on your computer. So what you can't do is make an app for a Mac or a phone. There are certainly ways to accomplish those things, but you write your code and you have the R interpreter on your computer, and R will do the calculations that you request. And so it has an easier kind of run-in phase to get operational, and it does particularly well at things that are oriented towards tabular data, which are the things we use in lab medicine. So we often have data in Excel files or CSV files, and it's particularly good at managing, cleaning, and displaying that kind of data.
Great. All right, and Stefan, will you tell us a little bit about what you think is the value of R then, this programming language applied to laboratory medicine?
Yeah, I think asking the question of value with sort of a return on investment in mind is a little bit misguided, and because I think you really got to think about analytics as having people who can analyze your laboratory data as an enabling technology or as an enabling capability. So once you have that capability, you'll find all kinds of opportunities to improve your processes or invent new uses.
Yeah, I agree. I mean, I think even outside of some of the things for reporting and visualization that Dan mentioned, and I know the examples you guys are going to show, I find now that anytime I encounter a problem and I don't have a solution, one of my first questions to myself is, could I do this in R? And a lot of times the answer is yes, even if it's making a connection between a database and something else that I previously would not have had access to do. So I do think you're right. It provides you with a tool. It's definitely an enabling technology that's becoming critical.
So that's exactly my experience as well, is that there's a lot of things that I previously thought, oh yeah, you can't do it, there's no support, I can't ask IS, if IS says it's not possible, now I can just do it myself, which is really, really cool.
We would be remiss not to mention that R and its entire ecosystem is open source and entirely free. So that's an important piece of the puzzle for those of you who might not be aware of that.
Absolutely. Patrick or Dan Herman, either of you guys have anything you want to add about what is R to you and the value of it for lab medicine?
I think one thing that's important is that R was really built by statisticians for statisticians, and I think that overlaps very nicely with a lot of the activities that we're doing on a day-to-day basis in the laboratory. Method validation, verification, method comparisons, those all fit really into R's toolbox.
Absolutely. And I know, Dan Herman, you also do some programming in Python, as I'm sure some of the other panelists do, but will you talk about what features or factors you think about when choosing between different languages, and what are maybe some of the pros and cons of R over something else like Python?
Sure. Yeah, no, I think the points that we've been making are very good ones. And for me, it's really the key is, what is your specific goal? And what's the team that you have available to achieve that goal? And as we're saying, R is a tool, and the things about it that make it, I think, very useful for us as individuals within clinical laboratory is, one, there's been a lot of work that's gone into R, making it easier to learn, easier to write code in a simpler, interpretable way, and easy to make that resulting code reproducible, so you can get the same results over and over again if you put in the same input. And so I use Python and I use R, but if I have a new question I want to ask and I want to explore method validation data, I might go to languages R just because I'm more comfortable with it. It's easier for me to write something that is clean and that I can pass off to someone else. But it really depends on what are your tools available already? Can you answer the question that you want to answer with your available tools? Or can someone else on your team do that? And if the answer is yes, then that's probably the way to go. But if you want to learn something new, I find R is a lot easier to learn and write things that are interpretable by others, and it's really, really flexible and powerful. And there's also a big community of us here and many, many others in the laboratory community that are creating tools to make it easier to use R to ask questions that are common to us as laboratorians.
Yeah, I think that's a great point, and we'll get into some of that later in the discussion about, I think R itself as a language is recognized within a very broad community of being very inclusive and being very helpful and open to new users. And I think within laboratory medicine, we have a very special community that's been developed of educators and users that are willing to help people. I don't know, because I don't participate in any other expert fields of expertise, to know if other groups have sort of popped up around this as lab medicine has beyond statisticians and data scientists. But we'll talk a little bit more later about all the resources that are very specific to lab medicine for R, which I do think helps accelerate that learning curve and people being able to use the tool. Okay, so why don't we spend some time then. We've got a basis of what is R, why do people think it's useful, particularly for clinical labs. So let's do some show and tell. So we'll first go to Dan Holmes, who is going to show us a report that he has generated through R, and walk us through kind of the basics of how he did that, what problems he's trying to solve, and how is R useful in that context.
Okay, so I'll just scroll back up here to the top and make that big. Is that displaying all right, everybody?
For me, it is.
Okay. Now, Dan Herman mentioned something very important, and it's something that Stefan is enthusiastic about, and I'm enthusiastic about, and that is R is reproducible. And so what we mean by that is if you run the same code, you get the same report. Now, you can produce reports in just about any kind of format you want. You can make static Excel reports or CSV files. You can report out to a database. You can make a PDF. You can make HTML. You can make web apps, and we're going to be seeing some of those later. But as you know, one of the things we need to do frequently is produce key performance indicator reports or some other static report, or even a research paper. This permits you to entirely code a research paper so that everything in the research paper, including the tables and the figures and the inline text that constitutes numbers, are constructed on the fly. And so if you alter the original document, the finalized document for upload will be generated by the script. Now, that's kind of a later stage thing that you would do. But here's a report that was originally coded by myself, but Janet Simons, who's a physician here, also picked it up and made it a little more user-friendly more recently. And so this is her report, and this is a static KPI report. So there's code that generates this report, including this table of contents and the hyperlinking within it. You can see that those are all links, and it'll take you to different portions of the document. All of this generates automatically from the R code. So each month we get the month's turnaround time, the raw data from the lab information system, and then we run the same script. And then you can even have the script be emailed out automatically. And I've even done things as like having text message sent to myself to alert me that the report has successfully gone out. So let's just scroll through some of the simple stuff. Nothing you would be surprised by. Tables about turnaround time, targets, collect to file results, receive to file results, and the number of minutes, and this is the 50th percentiles and the 90th percentiles of those. So tables are obviously possible. Some time series plots about how we're doing on hemoglobin, and this is all for the emerge. How we're doing on potassiums, how we're doing on troponins, and this is probably the fastest figure to digest in terms of turnaround times. Just scroll back out to see. So this is all of our emergency department orders for routine tests, which we classify as sodium, et cetera, and creatinine and troponin and whatnot. And so these routine tests are displayed in this spiral bar chart called a Rose plot. And it's really just a bar chart wrapped around on itself. And so this is the whole year in review. And the dark green is our order to collect. The middle green is our collect to receive, and the light green is our receive to file. And so we can get an assessment of that January is not as good. Maybe people are, they're too burned out over Christmas. And you can see the effect of what happens with things that go on in the year. Now, I can tell you for a fact that from here to here, the big change was we went live with Cerner. So everyone was having trouble with Cerner here. And so there's different similar kinds of plots all the way through. But the nice thing is we have to produce this as part of our accreditation and post it on the wall, and people need to be aware of what it is. So that work took someone a couple of days of futzing around in the past, and now it takes about 45 seconds. So that's an example of a static report.
Fantastic. Okay, so Stefan, you have a more of a web-based application that's also possible with R.
Yeah, let's see if I can share my screen here. Okay. So one of the cool things about, so we just saw static reports, and primarily the thing that's most straightforward to do with R is to build beautifully formatted static reports. But R actually also makes it pretty straightforward to build web applications. And you can deploy these web applications privately behind the firewall of your hospital system, which is what I've done here. What you're seeing here is a stem cell collection decision support tool. And the reason I built this is because what our lab found, the cell and gene therapy lab found, is that so we measure CD34 count, stem cell count, CD34 counts in autologous stem cell collections, so collections for patients who who donate stem cells before myeloablative chemotherapy and who get their stem cells reinfused as rescue therapy, autologous stem cell transplant. Sometimes we find that in some cases, but not all cases, that the stem cell count is lower after a freeze-thaw cycle, but not always. So what we've actually been able to do with some retrospective analysis is we identified 3 predictors for a drop in CD34 count. And but what happened as a consequence of this finding is that we categorically over-collected patients. We always collected twice as many cells just to be sure that we have enough stem cells. But now we built this tool where we can predict whether or not there's going to be a drop in the CD34 count, and I was able to wrap this algorithm into a minimalistic web app that our technologists can access at the time when the decision has to be made whether or not the patient needs to return for return collection. And so we estimate that. So I can show you what this looks like. So this is just a web interface in a browser. I'm entering some basic information. How many infusions do we anticipate, and what's our target infusion dose? What was the collection yield from today's collection? With the question being, do we need another collection tomorrow? And here are the 3 predictors. I'm not going to go into detail what they mean, but this is data that would be available, and then you'll get a recommendation. I'll tell you this is what your target dose is, and we don't recommend additional collection. Now let's say that this patient actually did have one of the predictors, then I'll get a notice that this may incur a significant CD34 drop, and a conservative estimate would be that we only have about half of what we need, and additional collection is recommended. And so based on a retrospective analysis, we estimate, and this is pretty new, we've just implemented this, but we estimate that we can prevent up to 10 repeat collections, which means 10 inpatient hospitalization days that are reimbursed by DRG. So this is pure money saved by the hospital, 10 days saved of CLABSI risk. So this is an example, I think, of where me knowing how to write an app in R and implement an algorithm really enabled us to move quickly on translating a research finding into practice, potentially resulting in significant savings and potentially risk reduction.
Very nice. Was this something that previously your lab folks were just doing this based on their intuition, or were they using Excel? Or is this something that, based on your research, you decided we should have an app for that and then took the initiative and built it?
Right. I think that's a great question, because I think the lab would, oftentimes find out these kinds of things, and then you have kind of a gut feeling. That this and this marker sometimes means that and that, but none of this. If you don't do it in a rigorous way, so we're going through a prospective validation of this model right now. I think that'll give us much more. Then of course it's the lab doesn't have the final decision of whether we recollect the patient. That's a clinical decision that gets made by our bone marrow transplanters. But the bone marrow transplanters will be much more convincing to them to actually have data that's captured by an app than an intuition that's held true over, or that we've used over months and months. So great question.
Yeah, thanks for sharing. Okay, and so our final show and tell is something that is of really current interest now. And so Patrick Mathias will show us the COVID operational dashboard that's in production at University of Washington.
Thanks, Shannon. So we've had obviously most labs have been integrally involved in the COVID-19 response, and early on we identified that we really needed a set of key performance indicators, and really need to be able to do a deep dive into our data to adjust things, not on a normal timescale for a lab, but really on a daily basis. And so I think our analytics have been important for that for us. And so this is an example of our COVID-19 dashboard. It's actually a public dashboard. This is posted and updated daily on the web. And this kind of shows our current volumes and some stats about the samples that we're testing, which are predominantly in the state of Washington. And this is actually just one panel of multiple panels in a more detailed operations dashboard that we're using internally within the lab. And so this is all generated within R using a package called Flex Dashboard. And this includes some metrics around our turnaround times. And so we're very interested in getting results out as quickly as possible, but at high volume. So we have some of our key performance indicators are samples resulted within 24 hours and samples resulted within 48 hours here. And then we are tracking the 5th, median, and 95th percentiles for our turnaround times overall. And we can do this based off of different groups of locations. So we have a tiering system to prioritize different samples. And in addition to turnaround times, we can also drill down into processing data. And so I'm going to scroll through and just highlight one of the other aspects of this that helps our pre-analytical operations, which is really understanding when samples are received in the lab by time of day. So this helps us adjust our staffing levels on the basis of when we expect samples to come in. And then finally, I'm not going to go through every aspect of this dashboard, but we also have some dashboards looking at our local rates of positivity. And so we do about 30 to, on a given day, between 30 and 50% of the testing for Washington State. So we are tracking positivity rates both by state and by county. And this has actually helped directly feed into our pooling strategy. So we are doing pooling for certain locations, and that is really directly informed by having some real-time data that populates this. And so this dashboard, the operational dashboard, is fed into, is basically updated daily, and we have a reporting website that includes all of our departmental reports. So this is updated automatically daily, and then this also feeds this public dashboard, which I think there was a lot of interest, particularly early on, in how much testing was available at UW, and so we're able to really just build on top of that existing infrastructure that we have for reporting and make that public.
Fantastic. This is really nice. And you know how much I like Flex Dashboard. It's one of my favorite packages as well. So we've seen a couple examples. This just scratches the surface of what's possible with R, but represents, of course, things I think that are very relatable to the audience, in that these are commonly encountered situations that people need solutions for. So maybe we should talk next a little bit about how you make decisions about when to use R versus a commercially available tool. Excel being one of the most common, but also some of the more emergingly popular business intelligence tools like Tableau or Power BI. So you guys want to weigh in on that, like how you would choose R over those, or what are the pros and cons? And then in a next question, we're going to get into what do you think it takes to stand these things up in a production environment?
I can start thinking about the business intelligence tools versus R. And I think what Patrick just set up in terms of the COVID, this fantastic COVID dashboard that they built, is a good example. At our institution, we have a lot of business intelligence tools that we pull from to do a lot of our reporting. So we pull data from our laboratory information system, and then we'll make some tables from it. We might do some cross tabulations, and that gives us a lot of ability to ask most of the common questions that we have the bandwidth to ask. But for us, when in the beginning of the pandemic, those tools were not actually flexible enough to keep up with the changes that were happening in terms of the different platforms that we were bringing on, the changes in our IS build. And so we actually had to build a new data infrastructure in which we leveraged R, because it was more flexible, because we could have more control over it, and it could allow us to change rapidly and manipulate the data enough to make it actionable. And the business intelligence tools that we had readily available were just not flexible enough for that. I mean, to me, I think the fundamental question is what is the best tool for the goal that you have. And if you can use a BI tool that you have in-house to do that, that's probably the right tool. But R really shines once you have it set up, because it makes things easy. But the activation energy is not a trivial thing, and so it has to be useful for what's going to be hit the bottom line for your laboratory.
I think Dan has hit on a lot of the important points there. My frustration with using tools that have a standard graphical user interface is that they don't have the flexibility to accomplish what you want. The COVID dashboard that we made for our operations answered similar questions to Patrick's. When I presented it to people regionally and provincially, they really liked it, but because of the activation energy, they recapitulated it in Microsoft BI. And many of the features could be redeployed in Microsoft BI, but frankly ended up being a little clunkier, and some couldn't be deployed. I just find that there's such a diversity and richness in the available tools, and there's such a huge user base that there's niche tools for just about every question you want. There's a web activity or some weird statistical analysis. R really shines in its ability to plug in tools from every imaginable place where people do this kind of work. Finance, advertising, your Twitter feed can be mined, databases. It really has a widget for everything. So you can think of it as the biggest Swiss Army knife in the world when it comes to data intelligence. And you can do whatever you can imagine, more or less.
Yeah, I think the integration point that you make is interesting. So our COVID dashboard is built in Power BI. We do a lot with Microsoft Power BI, but we integrate R into that because there are certain visuals that we can't make in Power BI, but we can use R, and then you can run your R script in Power BI. So it's, sometimes, as Dan Herman was talking about, it's whatever tools you have available and meet your needs. But R does have a lot of plugins to a lot of different things. So it really even extends the flexibility even more.
I would ask
Stefan or Patrick,
I would
you guys want to talk about what it takes to kind of stand this up, or why you chose a Shiny app over something else?
Yeah, well, okay. So to add to what everybody else has said, I think if you commit to learning R, you can easily also, build a Tableau dashboard. But if you commit to learning Power BI or Tableau, then you'll inevitably at some point hit a limitation where without knowing R, you're just going to be stuck. And so this is, I think, again, the point of that it's really enabling to learn to become comfortable, or at least familiar with the concept that you can write code and that you can express what you want in terms of computer logic. It's very, very powerful, and it's not part of medical curricula, which is very, very bad. So I would add that to what everybody else said.
I think that's a fantastic point. This concept of computational thinking, and then how it just shifts your perspective and your ability to look at problems in a different way, and think of really effective and clear logical solutions. I think that's a really great point. Thanks for making it. Okay. So let's then talk about what it takes to learn R. We've got a lot of interest in the Q&A where folks are asking sort of where do you start, what resources are available, how do you find a mentor. So there's a couple of recommendations that's been answered in the Q&A. I think we all probably have our favorite sort of starting box or where what we recommend. But I think we also, as I was mentioning at the beginning, have a really exceptional field in that though there are tremendous resources about R and how to do really anything in R, our field has done a great job of actually even honing those even further to make them very specific to lab medicine problems. So Stefan, I know you among us are the certified RStudio instructor. So why don't you start off this discussion about where people should start if they want to learn R?
Yeah, I think so. It's interesting that you bring up the certified R instructor. thing. This really goes back to when I was in that situation where I felt like this is something that you really have to learn, and how do I actually do it? And then I remembered that something that one of my mentors in medical school said to me, and that was, if you want to really learn something, you got to teach it. And so I sort of started by actually, I don't recommend everybody kind of start off like this, because I think it's a little bit easier now. But if you commit to actually teaching this kind of stuff to somebody else, this is how you learn it really, really well. And I'll get back to that point. But this eventually led to me becoming really interested in our education and building a course for residents and for pathologists and laboratory professionals, which I'm still teaching, and I'll get back to in a minute. So our studio, the company that builds the most popular integrated desktop environment, or IDE, which is really like a program that allows you to more easily write our code, is making huge investments, and I don't have any affiliation with that company, but they're making huge investments in education, and so this also helps make R more approachable to people who haven't been taught, who haven't programmed before. Now I think this is the point where I get to pitch our medicine conference. So I'm the chair of the R Medicine Conference, which is an annual conference that has the goal to promote reproducible data processing in clinical practice and research by using the R ecosystem. And we just flashed up a slide with the information. So this is. And this year there is a special partnership, excuse me, between AACC and R Medicine to build a forum for clinical laboratory professionals, and this isn't just lab directors, but supervisors and technologists as well, who are interested in R. And this conference will be held from August 27th to 29th. Virtually, and it'll include an introduction to R for clinicians or for healthcare professionals workshop, which still has some slots. And as a special promotion, if you are on this webinar today, you'll be able to take advantage of a 20% discount code off registration. However, if the Sunday, the 23rd, so this conference is coming up very soon, it's in a week. So Sunday is the last day to register and still be a live participant to the Intro to R course. And to get back to this course is essentially what's grown out of my my initial course I built for residents, and it's going to be an adaptation of that. So this is, I think this will be a really nice, gentle introduction to data science with R, tailored to people who are not primarily programmers and who are working in healthcare, and this includes laboratory professionals. And then I think the other place that I would really suggest looking at is the AACC annual meeting, and perhaps Dan, you want to say a few things about that?
Yeah. So we have a number of opportunities for learning R at the annual meeting. Presently, people like me may not be able to attend on site, but we're working on being able to present remotely. And so, for example, there's a Doing More with R course, which is sort of a secondary course that you would take after having some previous experience, so that you could build automated reports like we discussed earlier and dashboards. And then, excuse me, learning how to excel at data analysis with visualization. This is sort of a more gentle introduction by presented by some of the people here, and that would be more suited to people who had not had previous experience. And then there's scientific sessions and roundtables. So if this is of interest to you, whether you are coming in remotely, whether you are going to be there, there can be lots of opportunities to be exposed to what you can do. And I think, you have to have reasonable expectations. Learning R as a language is a process of learning how to say things, and computer languages are very, very strict on grammar. People are not, and so it does require some different kind of thinking. Sometimes you follow and you can do things immediately on your own. Sometimes you're just going to have to be aware that something is possible. You won't understand the context in which the educator is talking about, but later on when you start doing things, you will become aware of that context. You'll understand why they said what they said, and you can go back to your handout. So it is a mixture of learning how to do some simple things and being exposed to some possibilities.
So I would add to that I think the best first thing to do is to go into a workshop, into one of these workshops where you're actually going to be exposed, where they're going to do, where there's going to be interactive coding exercises. So I think this is a great first step. And then I think letting your brain a little rest for a little while and then doing another one is actually a great second step because repetition really leads to mastery. And then finally, if you really want to progress to really become familiar and confident, you gotta do your own project. You gotta commit to a project, perhaps something that you're doing with Excel right now, or maybe something that's new that you would normally use Excel for, and say, okay, this is simple enough. I think I can do this in R, and then do it in R. And this is how you become really good at this. And then finally, if you really want to learn this stuff, teach it. Yeah. Commit to if you're in the position that you're that you get to teach residents or medical students, that's a wonderful way to force yourself to actually really understand this material, and this is what's really worked for me. But that's not for everybody. That works really, really well.
Yeah, I will say, I first learned R from Dan and Stephen Master at a MSACL meeting, an in-person multi-day workshop, and it was grueling. I think people were crying in the class because Dan's just so fierce. And but it's a lot to stick with it. And then I went away and I just kept doing the exercises. But to Stefan's point, it wasn't really until I decided that I was going to set aside the time and recreate something that I had been doing in Excel, do it in R. When I look back at that code now, it's terrible. It's so clunky. But it was what I needed to do to get started. So most of these things have been in person in the past, but I think a lot of them are being converted to online formats. And so I think it's important that we even talk about, so the R Medicine is completely virtual conference, but I hope you all are aware that AACC just announced, I believe yesterday, that the annual scientific meeting actually is also going to be fully virtual. So my hope is that many, if not all of these offerings that we have on the slide will be available in an online format. Daniel, Herman, or Patrick, any thoughts about getting started with R? Or, we also had a really great question about how, if someone is starting out and learning R, how do you find mentors? And maybe, that question was about having somebody look at your code or troubleshoot your code for you, which can always be helpful, and it's typically because you've capitalized something or included a space or a comma or left out a bracket. So what do you think about providing mentorship and education and how people can get started?
Yeah, I can take that first. It's a great question. I think we had several questions in the Q&A about mentorship. Mm-hmm. And right now that's challenging to find mentors that are remote and not at your site. And that's something that we're thinking about in AACC a lot, as to how do we extend beyond these in-person teaching that we've been doing for a while. And as Stefan and several others said, a one-day session or a two-day session is great to sort of get your feet wet and understand what's possible and sort of appreciate that. But it takes that longitudinal project to cement that and really understand. We recently did teaching as part of API, and we created a message board for people to follow up with. But I think we really need to take this community that we've been growing within AACC and our medicine and others, and create a way for us to connect with others and make that pair. And it sort of exists right now as a one-off. You can reach out to one of us, and I'm sure we'd be happy to help you think about code, but you really need a strong mentor-mentee relationship to help you with those things that are simple to someone who's done this before, but might be really challenging when you're staring at your code and banging your head against the wall. So we're seriously thinking about that at AAC as to how to create that community and make longitudinal learning. But it's a good challenge. The other thing that I want to add is, you're all here because you want to understand R and how it relates to the clinical laboratory, but I'm sure each of you has a different goal. Some folks want to be able to use this and apply it to answer questions that you have, but for some folks it might be good enough, and like the right goal is to understand what is possible, and to understand what's possible so that you can set your expectations and you can help your local institution say, well, let's figure out how to do that, and to partner with others to actually do the coding. And so the literacy for understanding how to do data analysis, how to think about what's possible, might not require that longitudinal component as seriously as if you want to do the coding yourself.
That's a super point.
I'll second what Dan said. And what we teach the residents locally, we teach all of our pathology residents R at this point in data analysis. And maybe 50 to 75% of them stick with it and use it repeatedly afterwards. But almost all of them will come out with a much stronger sense of data literacy and understanding. I think the key thing is, even if you're not doing analysis yourself, what kind of data are you requesting, and what kind of overall analysis are you trying to plan to answer the question that you have in mind? And I think people residents in particular, or trainees, that our observation is they are much more well prepared to work with other, whether it's an LIS analyst or a data analyst. They're much better prepared to work with folks on a team to answer those questions, even if they're not writing code themselves, after going through and spending 8 hours learning the language.
I think this.
Yeah, and I think, go ahead. As Stefan was saying before, I think that translates to even beyond R, right? It's like any future informatics associated or data associated project, you come in with a much more robust understanding and perspective. Sorry, Stefan, go ahead.
No, I just wanted to second this general point about data literacy. And I do think that a great place to get data literacy is to take an intro to our workshop, because you're going to see what some of the very basic techniques are that the people that you ask for data for are applying to get you that data. And by just having been exposed to that, you can have much more better expectations to this and be a better collaborator with your information technologists. So I do think that, I think Mohana just asked that question. Can lab managers, scientists, or pathologists study this program, or is it a job of information technologists? So I think where we want to get to is that managers and scientists and pathologists and technologists and medical student residents, all of whom are not information, primarily data professionals, that they become literate enough, that they step up their data literacy to a point where they can become more efficient collaborators without necessarily becoming an R expert as everybody on this panel is. I don't think that's the goal.
And so there's another question about how do you expand use of R within your team or encourage use. And so, one of the other really popular and attractive things about R is the user community. And there are several of these local factions, right, called R user groups. So, and I know that several of you guys are very active or have even initiated those at your own institution. So let's talk about how you build the community and how you get others around you besides just trainees that you're responsible for educating. How do you get folks to invest the time or garner their interest in learning R?
Shannon, it's Dan here. I think when you show them what can be achieved, the interest is there. Mm-hmm. I think one of the problems, I mean, I was over at this conference in the UK last year when we used to travel on planet Earth, there was a paper presented by a major consortium of people that it was, gluing data together from many different sources. And they showed me the raw data. One of the PIs showed me the raw data, and it was this disgusting gigantic Excel spreadsheet filled with possibilities for error. And then at the dinner, I was like, why didn't you, I tried to be gentle about it. I said, why didn't you use like Python or R or something like that to manage all of that data? And they were like, I didn't even know it was possible to do this kind of work. And so part of it is just showing people what's possible. And like, just to throw some things out there, we networked our mass spectrometers to the lab information system with R. We wrote the code to do our outpatient requisition scanning in R. I know that seems bizarre, but when you only have one tool, you got to use it. And so we make dashboards, we parse weird files off the back of instruments. When you start seeing what is possible and you see that people have made packages to do different kinds of things, then you see new opportunities. And every time you look at something, well, I could do that with R, I could do that with R. And if you can get somebody else in your organization realizing what's possible without making the decision support people of your institution or the people who usually do analytics feel defensive. And that's one of the things I've seen. If you come along as what is traditionally thought of as just like Joe Blow clinical absorber of report or requester of report, and you show something that sort of upstages what is possible within your institution, you can get some fear and animosity. So you need to be kind of coachy and remember the people factor when you're jumping in there and trying to get people enthusiastic about it. And yes, in answer to Luzanne's question, there are tens of thousands of additional packages that will allow, maybe it's not tens of thousands, but there are thousands of additional packages to let you do specific niche applications.
Just going to follow up on something that Dan said because it relates to one of the questions in the box about accessing raw data. So I think I'll cut to the point, make it short. I think one way to approach this in accessing raw data is to really present yourself as the lab expert for that data. You know the data better than anyone else. And so provide yourself as a resource to central IT when they do have difficult lab data questions, they can come to you, and then it's more of an exchange of, they're going to provide you access, but you're also providing them some assistance in return.
That's a great point. Has anyone else had interest besides trainees for learning R? So like in your staff, and then will you guys comment on if there are active R user groups within your place and how that helps people also?
Yeah, I can take that one. So we have a very active CHOP R user group at Jones Hospital of Philadelphia, and with about 250 or more users from across the enterprise, and this includes a few people from Penn. From every single department of the hospital, and I think this is a great way to mitigate the issues when you're like the lone R user and you're a beginner and there's nobody in your group or in your direct surroundings. Who knows? I at CHOP here, I'm fortunate enough that I'm surrounded by a number of people who are experts, and that is, but I don't think everybody is as fortunate as that. But as Shannon mentioned, there are communities, and there may be one at your university that you can join, and where you can find people who may even work on similar things. And now with and now with COVID, these communities are all online, and which means that if you find your local R community, you're most likely going to be invited to something that's called Slack, which is a chat application for technical professionals. But it's pretty simple, so you just log in and there you can ask your programming questions. And so I think one thing that Shannon said earlier is really actually super important also when you're thinking about which programming language is right for me. The R, one of the biggest sells for R is that the community is very inclusive, very respectful, very friendly, and welcoming to new users. And there's truly a culture of welcoming new users among inside of the R community, makes it welcoming. So I think that's an important part of why I like to work with R, is because I know that that there's friendly people who can help me with things.
Yeah, agreed. And I know even our user groups are, local to different cities. So even if you aren't at an academic medical center, and, I think one of the neatest things about getting involved in our user group is that you get to see how R is used, as Dan Holmes mentioned, in like all different industries. And it's fun to see how people are using the same packages or functions that you are, but they're applying it to a completely different problem or question. And it really helps, I think, people push their boundaries and see what's new. Does anyone have any final comments? We're getting into our last 5 minutes here, and I know we wanted to highlight again, bring your attention to the R Medicine Conference, and then the folks from AACC may want to have a little close. But if there's anybody who wants to impart one final nugget of wisdom, please go ahead. No takers? Okay, do it. Jump in and learn R. It'll change your life in the way that you do things.
I'll jump in. Just you have a problem right now. It's a simple problem. It might be making a histogram that's pretty for some publication or some other just data cleansing operation, and make it real simple and get that intro book and just tackle some simple question. If you've done some programming inside of Excel, even with those little in-cell calculations, then you have the basic core principles to do some of this work. And there's lots of intro on YouTube where it gets you through the first sort of, hour of learning, and then you can do some simple things, or you can take some online courses that are for pay. But you could get a long way from some of the open source books that are out there or a YouTube video, and then you can answer that first question. Once you answer the first question and you see some progress, then you'll be greedy for more.
Yeah, for sure. Okay.
So there's one question about machine learning. Can you use R for machine learning in the clinical for clinical laboratories? So yeah, that's R has a very it has a lot of packages for machine learning, and there's a package under heavy development right now that's called Tidy Models, which allows you which takes sort of this idea of R of making things simple and not very wordy and user friendly, and takes it to machine learning. So there's definitely and this is going to help to bring things into production by really making them kind of more human readable and human understandable. So there's definitely a so yeah, R also has multiple NLP packages. So if there's any statistical method out there like NLP or like a flavor of it, it'll most likely be implemented as an R package. It's available for free.
Yeah, and often even if it was developed first in a different language, it often makes its way over to R because there's a lot of interest in a lot of our users. So, okay, well, with that, we'll turn it over to AACC. I want to really thank everybody for your participation. We had a great group. It's amazing to see this much interest in R. And thank you for all of your interactions in the chat. I hope we were able to answer your questions.
This concludes our discussion. I want to thank you all for the panelists for sharing their expertise, Dr. Heyman for moderating this webinar. I really appreciate all the activity the panelists did in the Q&A chat box. We will be collecting that information and making it available with the on-demand recording of this. That is the webinar for today. Thank you all in the audience for spending this time with us, and we hope you have a great rest of the day.